The big five acceleration equations. You'll use these equations to solve motion problems involving acceleration, displacement, time, and velocity. Over time, as you use these equations more and more, you'll get used to them and you'll become really familiar with especially two or three that are used more often than the other ones. But they all have their place and they'll all be used at some point in this course. Here they are. Solving equations. Whenever you're faced with a word problem, the first thing you need to do is determine what is given and what is unknown, including all the units. The second thing is you need to assign your vertical and horizontal positive directions, as well as define directions. Choose the positive direction which makes the most sense when answering the question. Now, it doesn't have to be north, south, east, and west. It could be forward. That could be your positive direction. It could be backwards. That could be your positive direction. It could be up. It could be down. Any of these things can be positive. It doesn't matter what you pick, as long as you pick one and stick with it. Check your understanding. A motorcyclist traveling initially at 12 meters per second west changes gears and speeds up for 3.5 seconds with a constant acceleration of 5.1 meters per second squared west. What is the motorcyclist's displacement over this time interval? So the first thing you need to do is determine your givens, unknowns, and assign a positive direction. So the first positive direction that we're going to assign is going to be northwest. We picked west mainly because every direction in the question is west. So we could have picked southwest, but I just picked northwest. Next, we're going to determine our givens and our unknowns. So our givens, in this case, we're going to have initially traveling at 12 meters per second. So that means our VI is 12 meters per second west. Changes gears and speeds up for 3.5 seconds. So time is 3.5 seconds with a constant acceleration of 5.1 meters per second squared. 5.1 meters per second squared and west again. Our unknown in this question is going to be the displacement over the time interval. So we're going to write displacement as our unknown. The next thing we need to do is choose an equation that you will use based on the variables you have as well as what you require. So what we have are these variables here, and the equation that makes the most sense is d equals vit plus 1/2 at squared. That's what we're looking for. We have vi, we have t, we have a, and again we have t. So this is a good equation to use for this particular question. 3. Solve and write your concluding statement. Well, let's rewrite our equation. So we have d equals vit plus 1/2 at squared. And now we're going to plug the numbers in. Vi is 12, time is 3.5, plus 1/2, a is 5.1, and t again is 3.5, and then we need to square that. When you plug that in your calculator, you get a displacement of 73.2 meters. Now in the question we have two sig digs everywhere, so our final answer is going to have 73 meters, and then our direction was west. So therefore d equals 73 meters west. Check your understanding. Starting from rest at t equals 0.0 seconds, so vi is 0. A car accelerates uniformly at 4.1 meters per second squared south. What is the car's displacement? So d is question, from its initial position at 5 seconds. T equals 5.0 seconds. Now you can see in the previous question I set it up as given and unknown, but once you've done enough questions, you can simply write all your variables down on one side of the page. So the next thing we're going to do is we're going to figure out what our positive direction is. We're told that they're moving south, so either southwest or southeast would be a positive direction. In this case, I picked southwest as our positive direction. Now what equation do we need? The equation that works best with this is that d equals vit plus 1/2 at squared. So d equals vit plus 1/2 at squared. D is what we're looking for. Vi is 0, so we're left with 1/2 a, which is 4.1, times t, which is 5 squared, and we get a displacement of 51.25 meters. We have two sig digs in our question, so we say therefore displacement equals 51 meters, and we're traveling south. So that's our final answer right there. An Olympic diver falls from rest, so we know Vi is 0 because they're falling from rest from the high platform. Assume that the fall is the same as the official height of the platform above water, which is 10 meters, so he's going to fall a displacement of 10 meters. At what velocity does the driver strike the water? So that's Vf. That's our question. Now we're missing a variable. The variable we're missing is either a or t. T we can't get from this question, but we can use a because there's a constant acceleration of any object falling on Earth, which is going to be 9.81 meters per second squared. Now typically I just use 9.8 meters per second squared, and then we need a direction, and we'll call that down. So I think this diagram here of the positive direction isn't correct. Let's not use that. Let's say that down is our positive. And let's find an equation that has VI, VF, A, and D in it. So this equation is going to be the most effective. It has all the variables that we need, so let's use that one. VF squared equals VI squared plus 2AD. VF is our question. VI, we're told, is 0. 2 times 9.8 times 10. That gives us a VF squared value of 196. We're then going to square root both sides, and we're going to get a VF value equal to 14. We need 3 sig digs in our answer, so we're going to say 14.0 meters per second, and then our only direction is down. So that means at the end of his dive just before he hits the water, 10 meters below where he started, he's going to be moving at 14 meters per second down. And that concludes our lesson on acceleration.